So my dear children, now we are about to investigate about several solutions. I have with me several solutions within this beaker. Within this investigation, we'll be observing what kind of a solution that can conduct electricity. What type of a solution that can conduct electricity. So, in here within this beaker, this is water, but however, I have added some acid drops into it. So this is called as acidified water. Only few drops of acids. Okay, it can be any type of an acid. Sulfuric acid, hydrochloric acid, nitric or whatever. Only few drops. Not heavy amount, but only few drops. So this is acidified water. So once again, I have prepared a small system that has two electrodes, right? These are carbon electrodes. So which are dipped in the solution like this. To investigate whether there is a flow of current or not, I have an ammeter. Then this is the this is the setup of two dry cells, and to connect and disconnect the circuit, here you can see there is a switch. So this is acidified water, my dear children. Now let's identify the solutions. This solution, the first solution. Here you can observe it in the bottom, there is some amount of salt also. So this is a salt solution. Solution over here that has a like reddish pink color, this one. This is kerosene oil. As you can see here, this one. It's pretty obvious to observe. Copper sulfate solution, right? This is copper sulfate solution. Then my dear children, finally, within the larger beaker over here, this is water. But however, this is distilled water, not straightforward drinking water, but distilled water. So what do you mean by distilled water? Distilled water means there is only water particles in it. There are no any other compounds. There are no any other ions. It's not like mineral water that contains several minerals within the water. This is distilled water. So it contains only water particles. Remember it. Now what we are going to do here is we are going to dip these two electrodes within each of these solutions. After that, we are going to see by turning the switch on which solution is going to conduct electricity and which one is not going to conduct electricity. If the solution is going to conduct electricity, my dear children, the ammeter reading will deflect to a certain direction. That will indicate that the solution carries electricity from one place to another, from higher potential to a lower potential. So now I have prepared the system by using acidified water. Let's turn on the switch and we'll observe whether there is a deflection in the ammeter or not. So I'm going to turn on this thing. So as you can see, we can clearly observe there is a deflection in the ammeter. See, when I'm going to disconnect the switch, once again the ammeter reading comes to 0. When I'm going to turn on, again it comes back. Again it's going to show a certain value. So we can see that acidified water solution is going to conduct electricity. Right. So now let's turn off the switch. We'll remove this system. Right, my dear children, now when I'm going to insert these two electrodes, it's important to at least wash, or now this solution in the previous case, no, so at least wash, or else you can use a tissue paper and clean these areas that has the previous solution like this. So it's better to clean it like this. Then after, we are going to insert the system to the second one. So the second system over here is the salt solution. Salt solution. I will keep the salt solution over here. Let's dip the two carbon rods. So it's important to keep these two rods away from each other so that they will not contact each other. It's important to do that. Now let's turn on the switch and observe. As you can see, once again, my dear children, there is a deflection in the ammeter. There's a clear deflection in the ammeter. That means the salt solution over here also going to conduct electricity. So when I'm going to turn off the switch, it comes back to the original position once again. So once again, now I'm going to turn on the switch. See, it's clear to us that there is a deflection in the ammeter. That means, my dear children, this salt solution is going to conduct electricity. That's why there is a deflection in the ammeter. See? Right. So salt solution can conduct electricity. Acidified water can conduct electricity. The two solutions. Once again, we are going to take out the two rods. Let's remove the salt solution. We'll wipe out now. Let's take the kerosene oil. Here we go. Let's turn on the switch and see. So we have turned the switch. So I have turned the switch on, but however, there is no deflection in the ammeter. Once again, let's turn off. Now it's on the off. Check, there is no deflection. Now once again we'll on. No deflection once again. No matter how much we are going to turn on and off, there is no such deflection like in the previous two cases, my dear children. So it's quite obvious to us that even though the switch is in the on stage, kerosene oil solution is not going to conduct electricity. It's not it's not going to conduct electricity. So once again, see, there is no deflection. So this is kerosene oil, my dear children. So let's turn off the switch. So let's wipe out the carbon rods. We'll keep the kerosene oil outside. So this is the next one which I am going to take is distilled water. So let's insert the two carbon rods into the system that has distilled water. Here we go. Now let's turn on the switch and observe what's going to happen. So once again, there is no deflection. As you can see here, there is no deflection in it. There is no such deflection. See, there is no deflection in the ammeter. See, there is no deflection. Even though I am going to turn on the switch, there is no such deflection within the ammeter, right? So we can come into conclusion that distilled water cannot conduct electricity. However, you can remember, when we use acidified water, it can conduct electricity. So within distilled water, there is no such observation, right? So let's remove the system and we'll go for the final solution. So the final solution is copper sulfate solution. So as usual, we have to wipe out. Now let's take the copper sulfate solution. Dip it carefully. Turn on the switch and observe. As you can see very clearly, there is a deflection in the ammeter. See, observe. There is a deflection. When I am going to turn off the switch, it comes to 0. When I am going to turn on, it once again runs back to a certain value. See? So it's very obvious to us that this copper sulfate solution is going to conduct electricity. That's why the ammeter reading is going to show a certain value. Right? See? Right, my dear children. So by conducting this activity, we can observe that there are some solutions that can conduct electricity and there are some solutions that do not conduct electricity. So let's head on to the classroom once again and we'll identify these two solutions. And once again, we'll write down our observations and conclusions from the activity. So my dear children, within this activity, we'll be electrolyzing this copper sulfate solution. For this electrolysis process, I'm going to use 2 carbon rods like this. These are carbon rods. Then let's dip these two in the solution. So this is the ammeter, a dry cell and the switch to turn and off the circuit. Now let's connect these two. The red color terminal indicates the positive terminal. Red color indicates the positive terminal. So this is positive terminal. And the black color terminal indicates the black color terminal. This one indicates the negative terminal. So here we go. I'm going to turn on the switch. So as you can see here, as soon as I'm going to turn on the switch, there's a clear deflection in the ammeter. Ammeter reading is showing now a value of a 0. Now it has been connected to the 3 ampere over here. So it's showing around 0.5 of a reading. Okay, the reading is actually not that much important. As you can see here, some kind of an electricity is going to flow through the ammeter. That's why it is showing a reading. So it's around 0.5 right now. So we'll check the terminals. So there is no such difference in the negative terminal, but however we have to take it out and observe. However, my dear children, within the solution, this is the red color terminal. Red color terminal is the positive terminal. right? So positive terminal is going to emit, see, gas bubbles. So it's emitting gas bubbles. Positive terminal is emitting gas bubbles, right? So let's keep the system for a while. Then we are going to check about the solution color. So in order to observe the color, my dear children, we have to keep the system for a while. So let's keep the system for a while within the same position, within the turned on position over here. As you can see, there are plenty of bubbles now coming out from the positive terminal. So we'll keep it for a while. Then after, we'll observe what happens with the color, and I'm going to take out this negative terminal, right? And I'm going to observe and I'm going to show that what has happened with the negative terminal or to the negative electrode which is inside the copper sulfate solution. So we'll keep the system for a while and let's observe what has happened with the color and what has happened with the negative terminal of the setup. So my dear children, as you can see here, now the rate of air bubbles which is coming from the positive terminal dramatically reduced. And also you can see that there is a clear weave of the solution as well. There is a clear, very clear weave. In the earlier, when I was starting this practical, my dear children, you are unable to observe what has happened with the negative terminal. There was no clear observation. But however, now you can observe there is a deposition around the, right, there is a like copper color deposition around the carbon rod. But in the previous instance, you can't observe it because the color of the copper sulfate was in like dark blue color. But however, now it has been dramatically changed, right? Even we can observe there is a very clear copper nature within the negative terminal of the electrode, right? So there is a clear difference in the color. Color of the solution has been reduced. There is a clear reduction in the color, my dear children. So let's turn off the switch and now we'll take out the negative terminal and observe very clearly what has happened with the negative terminal. See, as you can see here, there is a brownish color deposition around the, see, it's very clear to us. There is a brownish color deposition around the carbon rod of negative terminal. So here once again you can see this is the positive terminal which is in the red color. So this is still within the solution. So I have taken out the negative terminal. So there is a clear deposition of copper within the negative terminal. This is copper, my dear children. You can see it very clearly, right? And you even identify this color. So this is copper. This brownish color substance is copper. So by doing this activity, we can finally conclude that these are our observations. The copper metal, this is copper metal, no? So copper is going to deposit on the negative terminal. The color of the solution has dramatically been reduced right now. And the positive terminal is going to emit gas bubbles. So we'll head on to the classroom and write down our observations. Then we'll come into conclusions. So my dear children, here, as you can see here, this is the setup which I have prepared to investigate the electrolysis process of acidulated water. So this is acidulated water which is on the trough. These are the two gas jars or the test tubes. As you can see here, there are two carbon rods. This is our dry cell. So this brown color one indicates the positive terminal. This is the positive terminal. This is the negative terminal over here, which is indicated by blue color. Okay. So this is negative terminal or the negative electrode. Now let's turn on the switch and we'll observe what's going to happen. So as soon as I'm going to turn on the switch, here you can clearly observe gas bubbles are coming from both the test tubes over here. However, we can observe the gas bubbles are like large amount of gas bubbles are coming from the negative terminal. See, from the blue color, negative terminal, large amount of gas bubbles are coming out. From the positive terminal, once again gas bubbles are coming, but not that much as the other terminal. So we have to keep this system for a while, and we have to collect the two gases that's going to emit from these two terminals. Okay, so as you can see here, gas bubbles are now rapidly coming out from the negative terminal. So we have to collect these gases, right, my dear children? We have to collect these gases. So we have to keep the setup for a while. So let's collect the gases, then we'll observe by adding a splinter what's going to happen. So my dear children, so as you can see here, now I have moved the two test tubes in order to observe the volume of gas which is collected. As you can see here now, it's very obvious and very clear to us that more gas volume is being collected onto the negative terminal. See, and the gas volume which is collected at the positive terminal is somewhat lesser than it. Okay, more gas volume has been collected onto the negative terminal. As you can see here, it's very clear to us. Observe. However, the gas volume created at the positive terminal is somewhat less. So we have to collect. In order to observe, in order to get a good observation, we have to collect gases up to like certain kind of a height. So it's still in the, like initial stage. So we have to keep the system somewhat for a longer time to collect certain amount of gas. So once again, let's keep the system for a while and let's observe. So my dear children, now a certain volume of gases, right, has been collected to both the test tube right now. This is the positive terminal. There is a small bit of a acidified water column left within the test tube of the positive terminal. So this is the positive terminal. However, a good gas amount or good collection of gas can be observed within the negative terminal over here. Now what I'm going to do is I'm going to safely turn off the switch. We have to turn off the switch first of all, right? So now I'm going to safely dip my hand within the solution. Going to keep the finger beneath the right now. This is the gas which is at the negative terminal. So let's insert a glowing splinter into this gas and we'll observe what's going to occur, or what is our observation from the splinter experiment. Okay, so we have to insert a glowing splinter and we'll observe what's going to happen. So my dear children, now we are going to insert a splinter, but however, rather than inserting a splinter into this gaseous container, I'm going to insert this candle, a lighted candle. So we'll observe what's going to happen. Okay, so I'm going to insert this gas container into the lighted candle over here, right? So it's very clear to us that. So my dear children, it's quite obvious to us that it's going to emit a good pop sound, and yeah, as you can see, the candle flame is also going to put off, right? So what is the reason for that? Because this container, this gaseous container, right, it contained hydrogen gas. Hydrogen is a combustible gas. So upon inserting this combustible gas into a splinter or else to a flame, what will happen? The hydrogen gas is going to light up, and because of that process, it's going to combust. So because of that process, my dear children, right, what happens? It's going to emit a pop sound, and also the flame is also and also due to that thrust, the flame is also going to put off, right? So it's quite obvious to us that the negative terminal, the black colored negative terminal, right, the blue color wire, black color crocodile clip, the negative terminal, this one, it contained hydrogen gas. So my dear children, this is the container that is in the positive terminal. So within the positive terminal, the gas which is getting collected is oxygen. However, here now very less amount of oxygen is there. So you know that it's quite easy to observe oxygen gas. So what I'm going to do here is, I'm not going to show that oxygen is going to be produced by using the splinter case or by using the splinter experiment. Actually, it is somewhat difficult to carry out the experiment to show that there is oxygen, because as soon as I'm going to release my finger, right, your oxygen gas is going to come out. So if you want to get a clear view or clear observation, then we have to use somewhat larger container. So therefore, but however, my dear children, here the gas which is getting collected is the oxygen gas. Hydrogen is quite simple to collect. It's because hydrogen is a very lightweight gas. So like oxygen, it's not going to escape from a certain container, as it is always going upward, as it has very light weight. Okay. So my dear children, and there is another case. The other one is that now we kept this system for a very long time period. Now, if I'm going to keep the system for a shorter time period, I won't be able to collect this much of oxygen. The oxygen gas which is coming out from this electrolysis process of acidulated water is also very less. I told you that in the earlier case also, right? So I'm not going to do the experiment regarding the oxygen gas, right? But however, you could clearly observe that there was hydrogen gas within the negative terminal. Right then, so let's head on to the classroom once again, and we'll write down our observations and conclusions from the activity. So my dear children, within this activity, here also we are investigating about the chemical effect given out by the electric current. But however, what I'm going to do in this time is, I'm going to use that electrolysis process in order to plate copper on the spoon that I have in here, right? So first of all, I have a copper plate with me. I have scratched it by using a sandpaper. Then I have a copper sulfate solution. So if I'm going to plate copper on a certain surface, I have to use a sulfate or else a solution of copper. So here in this time we have used copper sulfate solution. Okay. So this is my positive terminal now. As the positive terminal, I have to use this metal plate which is copper. So I'm going to insert this into the system. Then let's connect it with the positive terminal of the dry cell, the red color one. So my dear children, the other case is that it's important to not to touch with the negative terminal, right? Negative terminal is now my spoon in here. So I'm going to insert. So you can see there are no any other metals which are plated on the spoon. You can see it very clearly, right? There's nothing in here. So I'm going to insert it and make sure that they do not come in contact with each other. Then we'll connect it with the negative terminal of the dry cell here. Right. So we have to wait for a while. Now if you check the spoon in here, you can see that there are gas bubbles which is getting created. So we'll wait for somewhat time and let's see what's going to happen. Right, my dear children, now let's see what has happened here. So as you can see here, it's very clear to us that there is a copper color, like brownish color substance on the spoon. See? So there is a brownish color substance. Right? I can wipe it off by using, right, a tissue paper. I'm going to wipe it off. See? So this substance is copper. Right? So copper is getting plated on the spoon. Once again, I'm going now. Let's remove the stain like this. And once again, I'm going to show it to you. So here you can observe it very clearly. See? So let's wipe it off. So I have wiped it off. So let's insert it once again. Right, so I'm going to take it off and you can clearly observe once again there is copper around the spoon. See? Right, so I can remove it by using this. See? So there is a clear stain. You can see it very clearly. There are two different colors. See? Right. So here we can finally conclude that within this system, when I'm going to provide electricity for the copper sulfate solution, for the copper plate over here at the positive terminal, then on the negative terminal we can plate copper, right? So always the object which the metal needed to be plated, it should be in the negative terminal, while as the positive terminal you have to use a metal rod or else a metal piece that we are going to plate should be on the positive terminal. Okay, so if you are plating gold, then we have to take a piece of gold as the positive terminal and the negative terminal whatever a necklace or else a jewelry, right? So this is how the plating process is being conducted even in the industrial level. So it's really simple, right? So this method is referred as electroplating. Here also we provide electricity in order to get or in order to give out a chemical effect, right? So let's head over to the classroom once again and write down our observations and conclusions from the activity.